Hello, Algebra 2 students. Today we are learning how to graph quadratics that are in factored form. We are going to start by finding the x-intercepts in the function. Yesterday in the introduction we talked about another name for x-intercepts is the zeros, or the roots, or the solutions. So if we want to find those roots, zeros, solutions, or x-intercepts, we can let y equal 0 and solve. When I do that, I get x equals 3 and -1. Now what I want you to do is write these x-intercepts as ordered pairs, because it's not an ordered pair 3, -1. It is the ordered pairs 3, 0, and -1, 0. So when I put these on the graph, they are two separate ordered pairs and are right here. The next thing we're going to take a look at is the axis of symmetry. A reminder that the axis of symmetry is the vertical line that divides the parabola in half. So if we look at these two x-intercepts, we know that the axis of symmetry is going to have to be halfway in between them. If I count the spaces, 1, 2, 3, 4, that means the axis of symmetry has to be 2 spaces away from each x-intercept. So here's my axis of symmetry that is equidistant from both x-intercepts. Now a reminder that the axis of symmetry is always written as the equation of a line. So the equation of this axis of symmetry is x equals 1. The next thing that you need to know is that the vertex is always on the axis of symmetry. So if it's always on the axis of symmetry, whatever this x value is going to be the x value of the vertex. So our axis of symmetry has an x value of 1. So our vertex has an ordered pair of 1, something. Okay, so we're going to take a look and see how to find that corresponding y value. Well, if I have an x value and I have a function up here, I can plug in that x value to get out a y value. So when I plug in 1, I get y equals 1 minus 3 times 1 plus 1, which gives me -2 times 2. So the corresponding y value is -4. So I go down 2, 3, 4. So that's looking pretty good. Okay, the last thing I'm going to find is the y-intercept. Remember that the y-intercept is always on the y-axis and always has an x value of 0. So 0, something. Well, just like we did over here, if we have an x value, we can plug it in to get the corresponding y value. So this time, I'm plugging in y equals 0, or excuse me, x equals 0. So 0 minus 3 times 0 plus 1, excuse me, y equals -3 times 1. The y-intercept is at 0, -3. Remember, another property of quadratics is that they are symmetric about this axis of symmetry. So if I have a coordinate here, I also have one that's symmetric across from that point as well. So my symmetry point would be at 2, -3. All right, well that looks good to me. I now have enough information to go ahead and graph my parabola. A reminder that the domain of all parabolas or quadratics is all real numbers, and that the range is y is greater than or equal to -4. It's the lowest point of the parabola, and then all of the y values are above that y value. Okay, so one thing to point out with this, it is already in factored form. The next example that we are going to take a look at is not in factored form. So when I go ahead and find my x-intercepts here, I have to first set it equal to 0 and factor. So one extra step this time. So what multiplies to -5 and adds to -4? The answers are -5 and 1. When I solve that, I get x equals 5 and -1. Again, we're going to write our x-intercept as ordered pairs, so 5, 0, negative 1, 0, and start by plotting those on my graph. The axis of symmetry is equidistant from these two ordered pairs. So I count my spaces. I have 1, 2, 3, 4, 5, 6, which means the axis of symmetry has to be 3 spaces away from both of these x-intercepts. So I go over 1, 2, 3, and here is my axis of symmetry. The axis of symmetry is a vertical line and is at x equals 2. So like we said before, the vertex is always on the axis of symmetry. So somewhere along here will be my vertex. It has an x value of 2. If I know the x value, I can get the corresponding y value by plugging it in. So y equals 2 squared minus 4 times 2 minus 5. So y would equal negative 5. Oh, that's crazy talk. It's not negative 5. Hold on. It would be 4 minus 8 minus 5, which would be negative 9. Much better. So down here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so vertex is at 2, negative 9. Now, for the y-intercept, we could do the same thing and plug in 0. So y equals 0 squared minus 4 times 0 minus 5. So y would equal negative 5. But also remember from your introduction to quadratics that the c value is the y-intercept. So you could save yourself a little writing by using what you know about quadratics right there. So I go down 2, 3, 4, 5. Notice that that y-intercept is 2 spaces away from the axis of symmetry. So the symmetry point would be over here at 4, negative 5. And there you go. I've got 5 wonderful points. I'm going to go ahead and connect the dots. My domain is all real numbers, and my range is y is greater than or equal to negative 9. All right, one more. In our introduction to quadratics, we learned that if the leading coefficient is negative, that means the parabola opens down. So before we do anything, we know that this parabola is opening down because of the negative out front. I'm going to start by setting it equal to 0. And I'm also going to factor out that negative 1. I get x squared minus 3x minus 10. By factoring out the negative 1, it will allow me to easily factor what's left inside. So I get 0 equals negative 1 times x minus 5 and x plus 2. What multiplies to negative 10 adds to negative 3. This gives me solutions of 5 and negative 2. Again, we write those as ordered pairs, 5, 0, negative 2, 0, and plot both of those points. So let's find the axis of symmetry. I go over 1, 2, 3, 4, 5, 6, 7. Okay, so that's not an even number, so that means that our y-intercept, or excuse me, our axis of symmetry is 3.5 spaces. So 1, 2, 3.5. So you have options on how you write that. Okay, I would go ahead and write that as x equals 1.5, which means our vertex is at 1.5, comma, something. Okay, so well, if we have that x value, how do we get the corresponding y value? Well, I'm going to go ahead and get my calculator. Okay, so my corresponding y value, when I plug in, I get y equals negative 1.5 squared plus 3 times 1.5 plus 10. And I get y to be 12.25. Now, how did I get that 12.25? I used my calculator. So when I graph that, it's going to be off my grid a little bit, so I'm going to go ahead and throw it up there, or I could have changed my scale. So my y-intercept is at 0, 10. This time I chose not to plug it in, I just used this c value up here. So 0, 10 is right here, which gives me a symmetry point at, remember this is 1.5 spaces away, so 1.5 spaces the other way is at 310. And there's my parabola. That looks great. It's opening down like I expected. I have the domain of all real numbers. This time the range is y is less than or equal to 12.25. Now, we've already talked about how to graph these on the graphing calculators. If you run into some issues where you need to verify your work, you can always do that. All right, well, what do I want you to do tonight? Okay, I want you to do 4, 5, and 6. You have 3 problems that I want you to graph, find the x-intercepts, axis of symmetry, vertex, y-intercept, symmetry point, domain, and range for all 3 of those problems. Tomorrow we'll go over them in class and see how we did. Thanks for watching my video.